So let's look into the fundamental product of set. Now we are saying we have the n distinct sets like A1, A2, A3 up to AN. So we have the n number of different sets. And you have the universal set U. Then the fundamental product of set is a set of the form. It's a set of the form A1 star intersection A2 star up to AN star, where AI star can be equal to A, or it can also be equal to A complement. Is that okay?
Yes, sir.
So it's simply like if you have, let's say, two sets A and B, and you are drawing a Venn diagram. So I can name this one, let's say A. Let me name here B. So we have so many intersections here. About 4 of them. We have about 4 regions here. Is it okay? Now one is this here. So you can name this one maybe 1. You can name here what? 2. They are all different regions. You can name here 3. Then outside all the 2 sets, we can name that one 4. Please, are you following?
Yes, sir.
Yes, please.
Now, what's the name of 1? This one here. It's only A.
Set A.
Or A only.
A only.
We don't want any B to be what? Part of it. So we can say that we can call that region 1 as what? A intersection B complement. You can call it A intersection B complement as one of the regions that we are talking about. So if you have found a fundamental product of given set, let's say A and B, then we just want to find the number of intersections that we can form. So we form all the intersections that we can get from a set of A and B. Are you okay? So like what we have it on the diagram here, we can name 1 as a region of A, but not B. It's intersection. So A intersection B complement. Now similarly, we can also name B as also B only. Or we can say that it's also B intersection A complement. Is that okay?
Yes, please.
Now what about the 2? Now we can name 2 as what? The region 2 is what? A intersection B.
Intersection B.
A intersection B. Or A and B. Is that okay? So far we have got
Yes,
about
please.
3 intersections. 1, 2, 3. And then outside all of them, this one. We can also call forward. For it outside it, we have A naught or A complement. Are you okay? And it's also outside B. We can also have also B complement. So we can call for as A complement intersection B complement. Is that okay?
Yes,
Yes,
sir.
please.
That's why I said A star can be A or A complement. So we are just forming the necessary intersection that we can get from the given set. And this is what we call the fundamental product. Now, if you want to know the number of sets that we can form or intersection we can form, it's given by n is equal to 2 power n. We made this y under the power law or power set. But this time, n is not the number of elements, but this one, n is the number of sets that are involved. So if you have A and B, how many sets do you have? You have 2, your n is 2. If you have A, B, C, you have n is 3, and so on and so forth. Now, if you have 2 sets, we must get 4 intersections, and these are A intersection B complement, A complement inter B. Now we have A inter B, and then we have A complement inter B complement. You get the 4 of them. So these are the number of intersections you can form by using 2 power n. 2 power n. So I've already illustrated this one back there. So I think you have the understanding of this. So the P1. P1 belongs to both A and B. Are you okay?
Yeah.
So therefore P1 is A intersection B. Now P2 is for only A. So you say that P2 is also A intersection B complement. Now you have P3 A complement inter B. P4 A complement inter B complement. Any question here?
No, please.
Now assuming if you are having ABC. ABC. Now let me start with P1. P1 will be what? A and B and C. So A intersection B intersection C. You get a P1 as one of the products. Now P2. What is P2?
B intersection.
Now P2 is for the circle of B here, and
A
also circle of what? And it's outside A. Are you okay?
Yes, sir.
Outside it, so not A. So you can say that A complement inter B inter C.
C.
A complement inter B inter C. Similarly, we have P3 also here, which is also outside the circle of B. And P3 is also outside the circle of B. Therefore, we have A inter B complement inter C. A inter B complement inter C. P4 is what? It's also outside the circle of C. So therefore, we have A complement inter B inter C complement at that. Peter, are you following?
Yes,
Yes,
sir.
sir.
Good.
Yes.
Yes, sir.
Now let's move on to P8. What is P8? Not A, outside B, and outside what? C. When it's outside, it's not or complement. Are you again? So
Yes,
therefore,
sir.
it's A
Yes, sir.
complement
Yes,
intersection B complement intersection B complement. Oh yeah, can we apply the Morgan law here?
Yes, sir.
It become what?
A intersection B
A union B
C all
union C
complement.
all complement.
B union C all intersection. All
A
complement.
union B
All
union
union
C,
B,
all
union
complement.
C, all complement.
A union B union C,
Union B,
all
union
complement.
C, all complement.
And here too will become A union B, all complement intersection what? C.
C.
Is that okay?
Yes, sir.
You're doing well
Yes,
this
sir.
morning. You're doing well this morning. And since we have 3 main sets A, B, C, then we must get 8 fundamental products, 8 of them. That's why we have P1 up to P8. Now let's check this example. Now suppose a list A contains the 30 students in a mathematics class, and a list B contains the 35 students in English class, and suppose there are 2 names on both lists. Find the number of students. A, only on list A. B, only on list B. C, on list A or B or both. D, on exactly one list. So this way you could see that we have a cardinality there. Are you okay? And you can also go by the fundamental product also to help us solve this problem. So we have, if you want to get the only A, we have the number of A at that, cardinality of A at 30, N of B at 35, and we are giving N of A intersection B. So the number of the students for only list A now will be what? 30 minus what? 20, which will be 10. Why so? Why so?
Because we don't want any access to intersect A.
You don't want what?
We don't want all the sets to intersect A. We want only the number for only people who are on list A.
Yes, if you look at what we have just done for the complement, I agree. A but not B is the same as A minus B. Is okay?
Yes,
A
sir.
but not be the same as A minus B. Are you following that sense?
Yes, sir.
Yes,
Yes,
sir.
sir.
A intersection not B. Is the same as A minus B. That we want only A, so we subtract all the B from 8. Are you okay? We did this one, the relative complement. Now look at something here. How many do you have in A? 30.
30.
So let's go back to the Venn diagram. Now this 30 here, assuming this is 30, are you okay? This is 30.
Okay.
Now this 30 is for P1 and P2. Is that okay?
Yes,
Yes,
please.
sir.
When you
Yes,
add the
sir.
P1 to P2, you get a 30.
Yes, sir.
That's set of A. So now I know A is 30. I know I know what? P what? P1.
P1.
How can I get my P2?
You
So we
subtract.
have A is equal to
Minus your P1.
P1 plus P2. That also
Yes, sir.
good. So therefore, what is A? A is 30. equal to what is P1?
10. 20.
20.
And we have to find the A only, which is P2. So we can make the P2 the subject. Are you okay?
Yes, sir.
So
Yes,
it
sir.
becomes 30 minus what?
20.
20.
Which is the same as
Yes,
A
sir.
minus. Don't forget, it's A minus what?
B.
P1.
A minus what?
P1.
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 A minus P1. Or you can say that A minus not B.
Yes.
So this is why the same as A minus B. This is why the same as minus B plus A or B minus A. Are you okay?
Yes, please.
That's a complement,
Yes, sir.
yeah. So that's what I was trying to say. So if you're having A intersection B complement, it's the same as A minus B. Probability for complement. Therefore, just go and then subtract the what? The B. So I want to go. So we have A only 9 8. Now you have N of A intersection not B. Who the same as A is 30 and not B now is what? 20. Not B is 20. It means this one is the same as what? We are now subtracting the intersection of both A and B from it. That is, we are not taking B out. That is not B. So we get 10 here. So similarly, you can also get B only, which is also the same as number of not A intersection what B, or the same as B minus what? Not A. And that
Yes.
not A is also the same as A intersection B. So it means we have B, number of the coordinate of B now is 35. Then you must subtract the intersection of all the two from it. Then you get it as what? 15. Is that one okay?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
You can also do a Venn
Yes, sir.
diagram. You can do a Venn diagram for this one. You can do a Venn diagram. Are you okay? Yeah, for it to make it very simple for you. Then you can do the B, C, and so on and so forth. Now, if you are the coordinate of A in B, we know we have seen this one already. It's equal to number of A plus number of B minus number of A into B. Are you okay? So we are given in all, how many are they? We don't know the total number. Are you okay? We only know what the mathematics, those for the English, and for both of them, and so on and so forth. So we have to find so you want to get the N of A in B. So we have the 30 for number of A, 35 for number of B. Then we have 20 for those that belong to both math and then the English. So you get 30 plus 35 minus 20, which you got to 45. So it means in all, they were what? 45 on the list. In other words, we can combine the two lists and then cross out the 20 names which appear twice. That's the same as what we get done. So D is saying that by what? We have to find those on the just one list. So how many are on just one list? So you will find your what? Only A and the only B. Add them together. So we got a 10, we got a 20, 15. So we add them together, we get only those numbers that will be found on only one list. So we are 10 plus 15. And that's what gives us 25. So that's the Venn diagram. So okay, you are using the Venn diagram. So in Venn 39 is 45. Number of A is 30. Number of 35. Now look at go for all. 15. I'll think 20 or 15.
Sir, 20. It's supposed to be 20.
Supposed to be 20. Good.
Yes,
So here
sir.
it's supposed to be 20. Therefore, we know that if I want to get the only A, I must subtract this intersection from it. So here it becomes 30 minus what? 20. That will give me our 10. Here it becomes
Yes.
5 minus 20. That will give my 50. As we got it from using that approach. Is it okay?
Yes, sir.
Yes, sir.
And these are some of the laws. We know this already from the logic, the equivalent property. So you know this. So when you go through it, it's similar to what we did over there. Any question?
No, sir.
No, please.
No,
The
sir.
time is almost up,
Yeah.
and we are left with only small thing.